next speaker is Dr. Abdullah Al-Amin, and his presentation is on economic implications of field size for autonomous arable crop equipment. Welcome.
Thank you. Let me share my screen first.
Yes.
Is it visible now?
Yes.
Hello, good afternoon. This is A.K.M. Abdullah Al-Amin, Elizabeth Creek Fellow at Harper Adams University and Assistant Professor, Bangladesh Agricultural University. I would like to share with you our research work. Me, together with Professor James Lowenbach de Boer, who is my Director of Studies, Kit Franklin, and my supervisor, Professor Carl Banded, have been doing research on economic implications of field size for autonomous arable crop equipment. This work is a part of large body of research demonstrated at the Hands-Free Hectare project in the Harper Adams University, United Kingdom. Post-war agricultural intensification through input use, crop and agricultural mechanization in Great Britain entails loss of biodiversity, and the United Kingdom continually adopting larger equipment to get the labor economics of size and labor endowment and the increasing field size to facilitate the agricultural mechanization, which results in loss of biodiversity, removal of hedgerows, and ultimately accelerating the soil compaction and GHG emissions. And however, the environmental management studies showed that small fields are rich in biodiversity, and the government of the United Kingdom has started 7-year transition away from the EU-based rules and encouraged the environmental land management schemes where the field size would play a substantial role for biodiversity conservation. It's taking time to change the slides. Okay, to reconcile economic and environmental gains, autonomous equipment are hypothesized as the sustainable intensification solution, and autonomous equipment would bring a paradigm shift of arable farming. Autonomous equipment has the potentiality to revolutionize precision agriculture and to facilitate the fourth agricultural revolution. Here is the short video of hands-free hectare operation in the Harper Adams University, United Kingdom. The state of the art and limitations of autonomous crop robotics. The existing studies mostly explored the cost-saving potentials, considering 1 or 2 field operations, and mostly they concentrated on the horticultural crops and few on cereals, and a very few studies hypothesized equipment performance and addressed the economic implications of farm sizes. Assuming constant field efficiency for all operations and equipment set, Lowenbach de Boer and his colleagues showed that autonomous equipment has the economies of size advantage compared to the conventional equipment sets with human operator, which is evident with the L-shaped flatter cost curve. They also hypothesized that autonomous equipment will diminish the pressure of field enlargement. However, due to data deficiency of field times and field efficiency, they were unable to test the hypothesis, and nothing is known on the economic implications of field shapes and sizes. To address this research gap, the objective of the study was to assess how field shape and size impact the economic viability of autonomous equipment in commodity crop production. We focused on commodity crop as we know that food security mainly relies with the commodity crops, and the study hypothesized that autonomous equipment would make it possible to farm small fields profitably. To achieve the objectives of the study, this research took the experience of hands-free hectare farm and follow the typical field path planning. In our study, hands-free hectare autonomous equipment refers mechatronic devices which are mobile, have the decision-making capability, and accomplish arable farm operations through predetermined path and itinerary under the supervision of human, but without the involvement of direct human labor and operator. Methodology of developing algorithms for field times and field efficiency estimation. Even though the logistics software is well developed in transportation and other sectors, however, for calculating the field efficiency and field times, there is no readily available softwares. In this backdrop, the study developed algorithms for estimating field times and field efficiency, considering field and equipment heterogeneity. And the study encompassed productive and non-productive times of headland turning and interior field passes to get the real scenario of the field operations. The study assumed 4 farm sizes with 90% tillable and 10% area were occupied for ecologically focused area, and we adopted and modified the hands-free hectare linear programming model developed based on the Purdue crop livestock model, which is widely used in the United States, Brazil, Colombia, Thailand, and various African countries. Results of the field efficiency with reference to field sizes showed that field efficiency differed substantially between 1 hectare and 10 hectare fields, but for the given equipment sets, field efficiency was almost the same for of 10 hectare to 100 hectare, and the hands-free hectare equipment set had comparatively higher efficiency compared to the 150 and 296 horsepower equipment sets with human operator, and the field size had least impact for hands-free hectare equipments, where the field times were longer for the small fields, which is mainly associated with the lumpiness of non-productive times. For instance, if the bean size and tank capacity highly matched with the requirement for the whole rounds, then the field efficiency was higher, and vice versa. Mathematical programming outcomes shows that conventional equipment sets with human operator required more operator and higher labor, and the small 1 hectare fields operated with 38 horsepower small equipment required maximum higher labor and operator time. And we know that agricultural labor is scarce and costly, and it is not obvious that agricultural labor will be hired at the assumed wage rate, that is 10 pounds per hour. And finally, the autonomous equipment found that it's demanded least labor and operator time for supervision. Return to operator labor management and risk-taking with reference to field sizes shows that net returns of small equipment set increased with farm sizes, whereas the large conventional equipments given the mixed outcome, and the returns of autonomous equipment are almost the same, irrespective of field sizes. The interesting finding of this study is that the study found that farming with autonomous equipment has the similar cost of production, irrespective of field sizes. However, even if the small 1 hectare field is operated with small 38 horsepower conventional equipment with human operator, the wheat cost of production was higher, which is evident in the upper L-shaped cost curves, and the autonomous equipment had the economies of size advantage as the conventional equipment had higher wheat production cost, which is about 30 to 40 pound per ton. Even though the study would contribute to the farm management, Agri-Tech economics, and environmental management literatures, the study has several limitations on algorithm development and economic scenario. For instance, if the field size are too small related to the size of the equipment, the algorithm breaks down and manual entries are needed. And future research will address the impact of field shapes, different field shapes, for instance, trapezoid and triangular fields, as this study mainly concentrated on the rectangular fields of different sizes. And economic modeling scenarios, the study could consider other equipment set which highly matched with the small 1 hectare fields. Considering the trade-offs between conventional agricultural mechanization and biodiversity loss, the study reached in the following conclusions. Small fields are operated with autonomous equipment are potentially a profitable solution for arable farming in the United Kingdom, and the autonomous equipment diminish the pressure of field enlargement. That is the rule of thumb of agricultural mechanization, that is get big or get out will diminish, already diminished, and which in turn encourage the biodiversity conservation. For instance, environmental land management schemes in the United Kingdom and agri-environmental schemes in European Union and elsewhere, and field size had least impact on the field efficiency of smallest equipment sets, and the autonomous equipment has the economies of size advantage compared to the conventional equipments with human operator, irrespective of field sizes. And the autonomous equipment diminish the labor scarcity problem, as we experienced that autonomous systems only require 10% of the machine times. Please visit our proceedings paper for further information, and I would like to extend my gratitude to Hands-Free Hectare Project for sharing the experience of autonomous arable farm operations, and my final acknowledgement goes to Harper Adams University and the Elizabeth Creek Charitable Trust for funding my study. Please ask question. Thanks for your patience hearing.
Thank you very much for your wonderful presentation. And it gives us another angle of looking at precision agriculture. It's really wonderful.